Okay. So, on number 6, again, we have parallel lines and a transversal. Now, those two angles that they're talking about, what are they? They're adjacent, right?
Yeah.
Adjacent angles are always what?
Corresponding?
No, they're supplementary.
Oh, yeah.
Always supplementary. In other words, up here, those are adjacent. They're supplementary. Those are adjacent. They're supplementary. Those are adjacent. They're supplementary. And even the two in the middle, like in this case, those are supplementary. So give me an equation I can write to solve that for x. What does it mean for this angle, which is 14x plus 7, and this angle, which is 10x plus 5? What does it mean if they're supplementary?
Well, they're...
What do they add to? What do supplementary angles add to?
Oh, 180, sorry.
Okay. So the equation is what?
The equation is, I can't see it, 14x plus 7 equals 180.
Hold on, no.
14x plus 7 equals...
No, add the two angles. Add the two angles together. That's just one angle. What's the other angle?
24x plus...
All right, let's take it one step at a time, please. Okay? Don't add them in your head. Tell me the two angles. The first angle, 14x plus 7. What's the second angle?
10x plus 5.
And what does that equal to?
That's equal to 180.
Okay. Now let's solve the equation. Don't jump ahead like that and do two steps in one. Do everything one step at a time. Okay, now combine like terms on the left side. What do you get?
Well, you get 14, you get 24x.
Okay. How about the numbers?
12.
Plus 12.
Plus 12, yeah. Equals 180.
180. Now what?
You subtract 12 from 180.
Good. Which is what?
180, that's 72.
No. Subtract 10. What do you get?
60.
Just subtract 10 from 180. What do you get?
Well, 70, so it's 168. Sorry,
There you go. The way to do that is to subtract 10 and then to subtract 2 from that answer. And that's how you get 168. Okay? So
and then you divide.
That goes in there 5 times?
Yep.
I don't think so. Does it? 24 into 168 goes 5 times? No, it doesn't. It goes at least 7. 7 times that goes 7 times.
Okay.
Okay, do you have a calculator in front of you?
Not directly in front of me, why?
Get one if you can. You should always have a calculator in front of you when we have a session. You're going to constantly have to do calculations like this.
Okay.
You have one?
Yeah.
Okay. So their question is x equals what? Well, that's 7. But they also want to know what those angles are. So what's the first angle? What is 14x plus 7? What is that angle equal to?
98.
Well, 14 times 7 is 98, but then you got to add 7 to it.
105.
Okay, so that angle's 105. Now, we don't really have to do the math on the other. We know that it's supplementary to 105. What angle is supplementary to 105?
75.
Yeah, and it's quicker to do it that way rather than to substitute 7 for x and do the math. Okay? So we've answered the whole thing. Is there anything else on this page you want to look at before we go to the next page?
No.
Sure?
Yeah. Actually, I want to look at number 5.
Okay. Good. This is an algebra problem. This is where you need some 2n plus 12 equals, is that a negative 4?
I believe so.
In other words, this is as big as I can blow it up. If I try blowing it up anymore, it goes on its side. So actually it would be helpful if you have this page in front of you, you could help me read some of it a little bit. But I think it is a negative 4.
Well, I had to turn it in.
Okay. We're fine. Okay, so what's the first step?
You multiply -4 to 2 into -3,
Correct.
and then it's 2.
I'm going to do that up here. Just I didn't give myself enough room to write, so I'm going to tell me what that answer is. Go ahead and distribute it.
2n plus 12 equals -8 plus 12n.
Very good. Now, I'm going to erase this to give myself some more room. Now let's solve this equation. Remember, the first thing you always have to figure out is which side you're going to put your variable on. What's the best side to put it on? If we want it to have a positive coefficient, what's the best side to put it on?
The one with the largest number?
No, I got two choices. I can subtract 2n from both sides, or I can subtract 12n from both sides. And that will put n's all on one side of the equation. Which side do I want n's on?
I would probably 2n.
Yeah, because that will leave a positive coefficient. So I'm going to move the 2n over to there, and that's going to give me 10n. And I'm going to move the 8 over to there by adding 8. That's going to give me 20.
22.
Now, do you see why that was advantageous to put the n's on the right? If I'd have gone the other way, this is what I would have got. I would have gotten minus 10n equals minus 20. So by going the other way, I avoided both negative signs. Everything was positive. And you're always better off if you can use positive signs instead of negatives. So always remember that first step when you gather like terms is to figure out which side you want to put n on. If I put it on the right side, it'll have a positive coefficient. If I put it on the left side, it's going to have a negative coefficient. Always go with the positive coefficient. There's no advantage to having n on the left as opposed to the right. Your variables are perfectly fine on the right side. Okay. All right. What else? We've done 6. We've done 5. 4 is pretty simple. You know how to figure out that angle?
To be honest, not really.
Okay. Well, let's do that.
Yeah, I do. Come on.
Okay. Here, I'll just go through it real quick. I assume that's 40. That's what I'm seeing. Okay. If that's 40 and that's a right angle, meaning it's 90, then this one has to be 50, right? Because they have to add to 180. All three angles of a triangle have to add to 180. So this one that they're asking about is supplementary with 50 because it's a linear pair. So what is it? What angle is supplementary with 50?
Give me a minute.
Remember I said a good skill to have in geometry is the ability to subtract numbers from 180. So you're subtracting 50 from 180. What's 180 minus 50?
180 minus 50 is, I know this.
130.
Oh, yeah.
Okay. All right. So we've done 4A. Let's do 4B. I'm not convinced you know how to do 4B.
Oh, 4B is easy. All you do is do 116 minus 180 and then subtract and then divide that answer by 2.
You got it. Okay, you convinced me. All right, let's go to the next page. Let's see. That was, we did 2520, I think. Yeah, that was, we started out there, and then we just did 2521. So let's look at 2522. Now, this is the page we just did. She may have just sent an additional copy of each of these. Yeah. So we've done everything that you have sent, and we've done everything on this page, except for number 3. Let's talk about number 3. We never really did number 3. When I saw number 3, I launched into my lecture on parallel lines and transversals, which I think is a very important point. The point being is that you only have 2 unique angles, right?
Yeah.
What's angle 1?
I know this. Oh, angle 1 is 180 minus 65.
Okay, give me a number. You can't write that down. I want that translated to a number.
I think it's 30.
You need to find yourself a calculator, Jack. Go get a calculator.
115.
All right. So I'm going to write that next to that angle, and we're just going to go through here and talk about this, and we're going to answer their questions. So angle 1 is 115. And those are the only 2 angles. All 8 of these angles are either 115 or 65. Okay? Obviously, all of the acute ones are 65. All of the obtuse ones are 115. That's one other way to think about it. Okay. Let me read the directions. Oh, God, I hate these directions. Describe a path to the measurement of angle 6. Okay, what's angle 6?
Angle 6. Angle 6 is probably.
Don't say probably. Remember, every angle there is either 65 degrees or 115 degrees.
Angle 6 is 65 degrees.
Okay, now describe how you know that. And unfortunately, you cannot use what I've taught you. You cannot use the fact that there's only 2 angles in this picture, and one of them's 65 and one of them's 115. You have to use this terminology over here. So why is angle 6 the same as angle 2?
Because they're corresponding.
Very good. Okay, and that was the path you needed, was to realize they were corresponding angles. Okay, then describe a path with more than one step to figure out angle 5?
Supplement.
Now, first of all, let me just add one thing. We figured out angle 1 on our own. They didn't give it to us. So that's the first step. So what's angle 5 and why is it that much?
Supplementary.
It's not supplementary. It's corresponding also. Angle 5 and angle 1 are corresponding angles. For the same reason that angle 2 is equal to angle 6, angle 1 is equal to angle 5.
Oh.
You see why? You see why it's corresponding? It's in the same position. It's in the same position on the bottom parallel line as the top one is on the top parallel line. That's what makes corresponding. The same thing with that angle and that angle. Those are corresponding.
Okay.
Okay? Now, angle 4. Describe a path with 4 different steps to find the measurement of angle 4. Okay. Wow. Can't tell you how much I hate that question. Let me make a suggestion. I'll give you 4 different steps. First of all, I can do it in 1 step, right?
Yeah.
What is angle 4 and why?
Well, angle 4.
We'll do it in 1 step and then we'll figure out a way to do it.
Angle 4 is 65 because it's vertical.
There you go. That's all you need. Okay. Now we're going to do it a different way. Now I'm going to do it in 2 steps. Angle 6 is 65 because it's corresponding with angle 2, correct?
Yes.
And there's a rule that says alternate interior angles are equal. So therefore, angle 4 is 65 degrees because it's alternate interior with 6. Got it?
Yeah. Yeah.
Okay. I don't know why we would want to do it in 2 steps, since you always want to do math in as few steps as possible. So I'm always doing angle 4 in 1 step. But if they want to make us do extra steps to get to angle 4, we can do it. Let's do it another way. Let's do it in 3 steps. Okay. Angle 2, this one right here, is equal to angle 8. Why? When I say equal, I mean congruent, but I'll use
because they're corresponding?
No, they're not corresponding. They're not on the same side of the line. If they're not on the same side of the line, they got to be alternate something.
We call it interior.
Exactly. Alternate exterior. They are alternate because they're on the opposite side of the transversal.
Yeah.
They are exterior because they're outside of the parallel lines, both of them. They're on the outside. They're not on the inside. Okay? So, therefore, angle 2, which is our 65-degree angle, is equal to angle 8. That's 1 step. And angle 8 is equal to angle 6 because they're vertical angles. That's 2 steps.
Yeah.
And angle 6 is equal to angle 4 because they're alternate interior. That's 3 steps. Okay? They wanted us to do it in 4 steps. Okay? Let's see if we can figure out a way to do it in 4 steps. Not quite sure I understand the purpose of this, but nonetheless. Okay. Angle 2 is equal to angle 8, because they're alternate exterior. Angle 8 is supplementary to angle 7 because they're a linear pair.
Yeah.
Angle 7 is equal to angle 5 because they're vertical angles. And angle 5 is supplementary to angle 4 because they're adjacent next to one another. So there's 4 steps. And by the time you get to that 4th step, angle 4 is equal to angle 2.
All right.
Okay. So, actually, a half hour is about all we needed for tonight. I want to do one last thing with our last 5 minutes. We haven't done this for a while. Let's do it as long as we have a little time. I want to see if you're any better on this. Don't use your calculator. Put it away, and you holler out the answers.
13.
Nope.
Negative 13.
Okay.
18. 80.
When you're doing multiplication or division, I want you to give me the sign first, even if it's positive. Okay?
Positive.
Positive what?
80.
The reason I want you to do that is because that's the first thing I want you to think about. I don't want you to think about what 10 times 8 is. What I want you to think about is what is negative times negative. That's positive. So if you yell out the sign first, you're thinking about it in the correct sequence. Same thing here. You're doing division. Is it positive or negative?
Negative.
Yeah, if the signs are opposite, it's always negative. If the signs are the same, it's always positive. Negative 4?
Yeah.
Okay, keep going.
0.
Keep going.
1.
No.
No, negative 1, sorry.
No.
0.
Yeah, it's basically when you have a positive and a negative together like that, just get rid of the positive.
Sorry.
And the problem becomes 1 minus 1. That's 0. Sign first.
99.
Sign first.
Positive.
Because even on these, I want you to think to yourself that you're doing a positive times a positive. That is equal to a positive. That's the only place you have trouble is with the signs. So let's
Positive 33.
So let's focus on the signs.
Positive 1. Negative.
Okay, this is a subtraction problem. Remember what I said. Whenever you have a subtraction problem where there is another negative sign in the problem, always turn it into an addition problem. How do you turn it into an addition problem? You make that first subtraction sign a plus sign, and you change the sign of the number that was being subtracted. So now we're going to have 6 plus a positive 2. Well, what's 6 plus 2?
8, so it's going to be negative
No,
4. Positive 4, I mean.
no, 8 was correct. You had 6 plus 2. 6 plus 2 is 8.
Negative 12.
Good.
Negative.
No.
Positive 110.
Good.
$11.
Sign first.
Negative
84. I don't even expect you to have, I don't need you to memorize how to do that one. I just want you to memorize how to do all single digit stuff and how to handle signs properly.
Yeah.
Once you get really good at this, and you will, practice will make you perfect at this. I guarantee it. There's no way you could spend 10 minutes a day on this without getting perfect at it. Think of it as a video game. You're going to master it. That's what you need to do. And once you do, you will be amazed at how much easier math becomes. Okay? Jackson, have a good one. I'll talk to you next time. Again, I'm sorry about tonight, but half hour is probably all we needed anyway.
Yeah.
All right. Have a good evening. Bye-bye.
Yeah.